Hello, everyone. Welcome to our webinar today. I'm so happy you could join us. Before we get Sal started, I have a few slides I'd like to cover off with you. The first one, of course, is to remind everyone that the Net Zero team is available whenever you want to connect with us. We've got our phone numbers and emails up on the screen. And we're happy that you could join us in our journey to net zero. So some housekeeping items. We just want to let you know that this webinar is being recorded and CHBA members will be able to access not only the recording, but as well the slide deck, and they'll be posted at chba.ca/NZ webinars. And you'll be in listen only for the duration of the webinar, but you will be able to have a chance to ask questions of Sal at the end of his presentation. So please feel free to use the questions section of the dashboard throughout the webinar, and I will make sure to relay those questions over to Sal at the end of his presentation. And also want to remind you that you can change your screen view by clicking on the little icon in the top right-hand corner. It's got 9 little dots with the word view beside it. So you can not only change the view that way in terms of what video screens you see, but you can also drag the slider in between the two major sections back and forth to make the slideshow versus the webcam smaller or larger to however best suits your choice. We also, of course, want to take this opportunity to thank Owens Corning, as they've always been a huge sponsor of ours. So they are our silver sponsor right now. And we want to remind you that both Sal and Lewis are available for you to connect with. We've got their contact information up on the screen. And like I said, you'll get the slide deck at the end. So you'll have the information from them as well. So thanks again, always to Owens Corning for being such a big supporter of our efforts. Also want to say a quick thank you to our other sponsors, All Weather Windows, BASF, Enbridge, Fortis BC, and Panasonic. So for today's webinar, as you know, you've tuned in to find out more about how to turn basements into valuable, comfortable, healthy, and safe living areas. Sal is going to talk a bit more about why, with people working from home and having kids attending school from home as well, that having a home office or other livable space in the basement has become a bigger priority for many homeowners or households. And so he's going to tell you a little bit more about how to unlock the potential of adding living space that is healthier, safe, comfortable, durable, and also minimizes radon ingress. And for those of you who signed up on our website and saw all our notifications, you'll also know that there's a follow-up seminar called The Science of Building Better Basement. It's being hosted by Buildability. The CHBA specific session is being held on November 4th. I believe there's only a few more spots left, but it's basically first come, first serve. So the first 30 participants get in on that session. And if we need to open up some more seats, there are potentially some more dates available or seats available on October 21st and October 28th. So feel free to reach out to us if you're not able to register. So if that the first 30 seats are taken, and we'll get you set up with seats in one of the other sessions. So as a reminder, this webinar is being recorded and you'll be able to find everything at chba.ca/NZ webinars. That's also the space where you can find the registration information for that webinar, or sorry, for that follow-up seminar, and for any of our archived recordings. So before I pass it over to Sal, we do have a few polls we want to do. So I just have to find my way back to that. So the first poll we want to do is on membership. And we would like to see who here is a builder versus a developer versus, what do we have here? Renovators, trade contractors. We've got a bunch of different options for folks, and we'd love to see a high level of participation so that we can get a sense for who's here. So for those of you who are just joining, if you're able to jump in on that poll, we're almost at 50%. I'd love to see maybe 75% participation in the poll. Right now, the race is being led by builders and professional services. And let's see, I think we've got enough information now to end the poll. Thank you so much. And I'm just going to share the results with you. So you should be able to see that on the screen. For some, I don't know, Sal, are you able to see the screen? Because for some reason,
Yep.
You are? Okay, because I can't see anything on my screen anymore.
Yeah, so the majority are builders and professional services provider.
Perfect, great, thanks so much. Yeah, and for some reason my screen has gone black, so I'm not sure what that's about. All right, so perfect. So we've got a couple more polls here. So I'm just going to pull up the next one. we have here. Stop sharing. And then I'm going to pull up the next one, which is the location. So we want to see where everyone is coming to us from. Are you here from BC, Alberta, Saskatchewan? And again, I'd love to see another high level of participation so we can see where everyone's coming in from. And we're almost at 75%, just a few more people to reply, and then I'll end the poll. Wonderful, thank you so much, everyone. I'm just gonna end the poll now, and I'm gonna share the results. So you can see here that the majority of folks, almost 50%, are from Ontario, and then we've got a nice spread, high level of BC and Alberta, almost tied there. It looks like, yeah, they're tied. Saskatchewan and Manitoba, same thing, and some from Nova Scotia. Thanks so much, everyone.
The presenters from Quebec, so one presenter.
And one from Quebec. Awesome. All right, so the next webinar we want to ask is, how do you currently insulate your basements? We're keen to see whether or not your approach is from the interior, exterior, or if you do a combination of both. So we can see again what everyone is up to these days. Oh, it looks like interior is winning the race here. We've got a few more people if they could also participate. We're almost at 75%. If there's a few more of you who would like to participate, that would be great. All right, looks like it's slowed down. So we're going to end the poll here and share the results. So you'll see here a high level of people doing interior approach. And then there's some who are doing a combination.
That's interesting, 21% doing a combination. Yeah.
Yeah, I thought that was interesting too. Okay, and then the last poll we've got here is, do you currently insulate under your slab? So yes, Al, do you see a lot of builders doing the combination, or is it usually one or the other?
Not in my region, mostly the interior in Quebec. So it's interesting to see that there's a hybrid audience.
So for this one, we've got, if we can get a few more people to participate in this last poll here, and then I will end it. All right, great. Thank you so much. And I'm going to share the results. So it looks like there's only a few people here who are insulating under the slab, and then the rest is split between no or sometimes. All right, thanks so much. Now that we're done with the polls, I'm going to pass the controls over to Sal, and I'll let you know when we can see your screen there, Sal. Great. All right. We can see your screen. So I will turn off my webcam and let you do your thing.
You can see my screen, Sonia?
Yeah, it's perfect. Now we can see it in slideshow view.
Perfect. Well, thank you so much for the intro, Sonia, and thanks to everybody for attending this session. I'm happy to be here and happy to have you attend the session. Hey, just a quick intro. I'm Sal Charlo. I lead the demand creation team and codes and standards team for Owens Corning Canada. We're there to help all of our customers across the country to help you integrate some of our solutions and to help us move along, help you move along the path towards net zero ready performance. What we want to talk about today really is, as Sonia mentioned, I think COVID has shown us that the trend is more people are going to be working from home in the future. And so basically we have an opportunity to turn the basements into valuable, comfortable, healthy, and safe living areas. So what I want to talk about today here, just touch a little bit upon how to go about achieving that by looking at, exterior basement insulation options and drainage systems, split insulation, interior basement enclosure systems, and then I want to talk about radon control, which is really important nowadays as there's more and more presence of radon across the country. And so we want to make sure that those spaces that we're providing, those livable spaces that we're providing, are also very safe. And as Sonia mentioned, this is, so I'm going to touch about some of the big lines, but we're going to go really deep into these with Mike Leo and the buildability team on the upcoming Better Basement session that Sonia had mentioned. So if you haven't registered, please do so. And like Sonia mentioned, if the first 30 spots fill up, we do have some other dates that we would want to open up. So really, why is there a need to build better? I mean, first and foremost, the climate is changing. And so not only do we need mitigation strategies, but also adaptation strategies, because climate change is real. We're starting to see more rain, more snow, more intense variations. And so our building enclosures need to be able to withstand to those aggressive changes that are happening, because when people buy homes, our customers buy homes, they want to buy homes for, it's a durable investment, a long-term investment, but they also want it to be comfortable. And we need, so our enclosures have to adapt to these changes. So really today, the goal of the presentation is really to show how do we change that, with the perception that a basement is just a storage area, and how do we turn them into comfortable and safe added living spaces that are more comfortable, that really add value to a homeowner's investment. So that's kind of really what I want to talk a little bit about today. So what are the critical control layers that need to be addressed in order to make the space a safe living area, comfortable living area? So moisture, that means better air quality, no dampness, no mold, no smells. Oftentimes, if a basement's not done right, when we go down to the basement, it doesn't feel right from a moisture perspective. From a thermal perspective, it needs to be comfortable. We're going to be spending time there more and more time. We want it to be comfortable year round. That's the key. And we want to also make sure that from a thermal comfort perspective, that wherever we move about that space, we feel comfortable. From a durability perspective, we don't want condensation to happen in basements. And you'll see that there's different ways to insulate the basement, and there's different things that you need to think about depending on how you insulate them to make sure that durability is achieved. And then soil gas. I mean, that's an important one. You'll see at the end of my presentation. It's the silent killer. We don't know it's there if it is there, and if it is there, it's serious, and that's a health and safety issue. And you'll see some innovative ideas that I'd like to present to you that help address health and safety from a soil gas, radon gas perspective. So really water management, I think that's a simple one. We're starting to see more and more floods, and obviously the basement is the first area that's going to get hit when that happens. And if we can make our basements more resilient and make sure that the products that we use and the enclosure systems that we incorporate are not susceptible to moisture damage, it could be a valuable investment. So we want to make sure the system addresses water management. So what are some good practices? Obviously, to eliminate in terms of waterproofing, and I think we see this done pretty typical across the country, but not as much as I think it should be done. In terms of waterproofing, incorporate dimpled membranes on basements on the exterior. That eliminates hydrostatic pressure, and so even if there's a buildup, an accumulation of moisture in the soil, those membranes prevent water from infiltrating into the basement and affecting the other components that we find on the other side. Dam proofing, and that's pretty standard, but also capillary break. I know in Eastern Canada, it is not a detail that I see quite often, but it's a great detail because, I know Joe Stuber always says, hey, actually John Straub, concrete sucks. It actually picks up moisture through the pores, through capillary action on the soil that it's sitting on. And that can actually, depending on the fineness of the pores, it could actually draw up high levels of moisture, which would come into contact with some moisture susceptible products that you might find on the inside. So it's a simple detail, cost-effective detail that should be incorporated, in my opinion, on every build to really manage moisture from a capillary rise and improve durability and comfort. And then just water management at the source. I mean, it seems simple enough, but just making sure that going back to basic principles, building science 101, make sure that your slope it's got the right grade away from the building. I mean, you can appreciate that if there's a big rainfall, there's a tremendous amount of moisture that is discharged from the roof right where the footing is. And if that slope is not evacuating that moisture, it sits there. And if you're in the fall where you're hovering between, above zero temperatures and freezing temperatures quite rapidly, that's where you can get some issues. So just simple measures, say good gutters, making sure that the gutters, that the downspouts are bringing the moisture away from the wall. You don't want moisture sitting at the wall. And even for low-hanging windows, when you use window wells, making sure that those wells are drained, not just filling them with any type of backfill, but good granular backfill with proper drainage to prevent water from filling that spot, that well, and then actually coming into the building. So just simple moisture management. In terms of energy efficiency, I know we have a tendency to focus on attics and above grade, and that's where we try to insulate them to the max. But we oftentimes we forget about the important sort of contribution of basements on the energy consumption scale. So you can see that if 50% of the energy used in a house is for heating and cooling, you can see that when you further break that down, 25% of that energy is used in basements, a little bit more than walls. Windows is another big one there. So I think we pay a lot of attention on all of these points on the second circle, but we forget, we pay little attention to basements. We insulate them to very low levels, and I think we could do. There's a huge opportunity to do better, which would then really ensure long-term performance, comfort, and resilience. So one of the options is exterior basement installation. I saw on the poll that we ran with Sonia ran that the majority are using interior installation strategies or systems, and surprisingly, a few are using hybrids. So I'm assuming some on the outside, probably below grade, and then finishing the rest of the insulation on the inside above grade. But so what's the advantages of insulating on the outside? There are systems that are available in the marketplace. So using the right product that's water repellent, that's not moisture sensitive, can actually provide a good barrier for that concrete. Remember that concrete, it's gonna be subjected to temperature variation, hot and cold, and so it's gonna move when you insulate it on the inside. If you put a blanket of insulation on the outside, the temperature stays more constant. And even if that concrete were to crack, and it probably will at some point in time, it's protected. There's that shield on the outside that would minimize the risk of water infiltration. And so there's a lot of advantages when considering exterior insulation. And there are some innovative products in the marketplace that actually even incorporate a drainage layer that's certified by CCMC, so that it could do the same function as the dimpled membrane, or in addition to the dimpled membrane. And you always need that waterproofing, the damp proofing membrane with these systems. Sorry. And one of the whenever we builders that have used these systems, their first challenge that they had to overcome was, how do you finish the portion above grade? How do you protect that portion above grade? And so I just wanted you to be aware that there are some innovative off-the-shelf products, cementitious coatings that can be applied right on top of the insulation. One of the products that I've suggested here is a product from Gemite called Thermal Shield Foundation Coating, and it's very durable, it's very effective, very easy to install, and then you just cap the top with some type of flashing. So it is possible to do. It's been done before. It's aesthetically pleasing, and it's got a lot of great advantages, something that you might want to consider. The benefits in terms of risk of condensation. So we just recently did a study on basements where we looked at the surface temperatures for both the concrete slab and the walls and risk of condensation with different insulation options. This is one of them. So when you're insulating on the outside, so here in Montreal, when you look at when we did the analysis, we always do it for worst case. So the design temperature for winter condition is minus 23 degrees. So basically, when it's minus 23 outside and 20 degrees inside in Montreal, you can see the surface temperature of the concrete is around 15 degrees. If I were to compare that to a 2x6 bats in R20 and poly wall, that temperature would be minus 21, so much colder. And so you can see that insulating on the outside keeps the concrete warm. It actually even acts as a buffer, as storage, so that it can re-radiate that energy at night. So the advantage, the risks of condensation are very, very low. when you're insulating on the outside. So really, that's one of the main advantages of insulating basements on the outside. Another important factor is, especially if you're considering code compliance under the performance path, where you actually model the house and you kind of make sure that the overall energy consumption doesn't exceed what is required by code or whatever level of performance you're trying to achieve, is an insulated ledge block, a structural insulated ledge block. So Owens Corning has one. It's called foam glass. And there is a significant amount of heat loss that happens at that area, especially if you're using exterior insulation and you're not using some type of insulated ledge block. So that's an opportunity, an innovative product that could also be, you could also consider to help minimize the heat loss at that part of the wall, and obviously to optimize the performance of the basement of that lower living area. And then there's a typical basement insulation strategies where you're installing a moisture barrier up to grade on the inside of the foundation wall, typically wood studs with some type of insulation, the vapor barrier. That's what we typically see or have seen across Canada, and that's R12, R14, R20 bats. However, you can see that when we're using those types of systems, if you look at the temperature of the concrete on the inside, the inner face of the concrete right behind the bats, for the different regions, so Winnipeg being very cold, Montreal, and then warmer regions like Vancouver, you can see that it's still very cold. And so it's important to really minimize air leakage and water vapor movement when we're using those systems. They're very effective, but you really have to pay a good good attention to continuous air and vapor barrier. That's critical because you can see that the maximum relative humidity that surface can tolerate right at the surface of the concrete is very low. And so if you have a little bit of water vapor that makes its way past the vapor barrier, past the bat, and onto that surface, you're going to get condensation, and you don't want that to happen. The other risk is in the springtime, inward diffusion. And so in the springtime, all of the moisture that was actually being pushed out in the wintertime during the heating season that was absorbed by the concrete, or any rain absorption that occurred, in the springtime, the sun is actually hitting that concrete surface above grade and driving water vapor back in. And so if you've got the polyethylene vapor barrier that's vapor closed, and it doesn't allow it to make its way all the way through and dry, you get condensation. You can see pictures of a typical basement where you get, pooling of water or condensation on the poly. This is because of this, what I just described. This is what's happening. It's that inward vapor drive. And so, those vapor barriers that we're using in basements with bats they need, they're probably not a good thing. Obviously it protects vapor diffusion in the wintertime from going out. But when it comes to radon diffusion inwards, it actually blocks and condensation could occur. So there are some better alternatives like smart vapor barriers that can actually close or open up depending on what it needs. It'll close up in the wintertime so that it doesn't make the water vapor go to the cold surface. And in the springtime, it'll actually, in the presence of humidity, it'll open up to allow continuous drying to the inside. Another way, other than using a smart vapor barrier, is consider using a low permeance continuous insulation up against the foundation wall, and that's going to manage vapor drive or vapor flow in both the in the wintertime and in the summertime, as well as in the spring. And so these are hybrid systems that work very well. You'll see later on there are minimum ratios that need to be considered and respected so that they work well with or without vapor barriers. But the low permeance prevents water vapor from diffusing in, and in the winter time, it provides a warmer surface so that any vapor that would get to that area would not condense. And so here's a study that was done, and I'm sharing from building science labs. And if we look at an R2x4 stud wall in a basement with our 12 bats, and a polyethylene facer, you can see that the red line here is the actual temperature throughout the year. When you're above that line, the dew point temperature of the air, typical air and relative humidity found in a basement. When you're above that line, condensation you're above the dew point, so you're okay. When you're below the line, condensation will occur because you've reached a temperature too cold for the vapor that's present and it condenses. So that's what typical poly. And when we did the same analysis with just 1 inch of extruded polystyrene, low permeance insulation up against the stud wall, and then with fiberglass insulation in front of it and a vapor barrier, you can see that there is a lot less risk of condensation. And so it works. And so, those are the things that you need to consider when you want to turn the living space into a year-round space that's comfortable, that's durable, that's resilient. How do you manage vapor flow? And there's a couple of ways that I just showed you that you could consider. So here's, again, I mentioned when you're looking at a hybrid wall, so insulation up against the concrete wall and then fiberglass or mineral wool insulation in the stud cavity, you can see that the temperature of the concrete, the inside face of the concrete, in Montreal, when it's minus 23 outside, it's actually minus 21 degrees. And when you go to a hybrid system, so R14 bats plus, let's say, an R10, 2 inches of extruded polystyrene, you can see that it gets much warmer. And so those hybrid systems actually reduce the risk of condensation. It's actually 16 degrees warmer than our typical R20 system right up against the concrete wall. And then obviously in terms of energy savings, so you can see that in a report that we just ran with Morrison Hershfield, we calculated what we call the below grade foundation perimeter heat loss, so the amount of heat that your basement would lose based on your complete enclosure system per meter of concrete concrete wall length. You can see, again, I focus on Montreal, it's the colder region. An R20 wall with R12.5 continuous insulation, you can see the different heat loss factors. With no insulation under the slab, you can see what the value is. And then when you start adding insulation under the slab, you can see that there's a significant amount of energy, of energy savings. There's cost reduction when you also incorporate under slab insulation. And we'll see the benefits of that a little bit later on. But the point I'm trying to make here is that, so the first thing you might want to consider is a hybrid system versus just a single system on the inside of your foundation wall. And if you're not insulating under your slab, even though the code doesn't require you to do so, there is an energy savings benefit to doing insulation under the slab. And there's some added benefits that I'll walk you through a little bit later from a thermal comfort perspective, as well as from a safety perspective. And so you can see, I'm just going to move my camera out of the way here. You can see that when you're considering a hybrid system, it's important to have the right ratios of low permeance versus fiberglass or mineral insulation, just to minimize the risk of condensation on the condensing plane. And so in the study that we ran and the report that we have, under the most severe conditions, which is worst case, we've looked at the ratios or the options, the split that is going to allow us to minimize the risk or prevent the risk of condensation from happening. So you have to balance it properly in order to have a durable hybrid system. And so when it comes to our foam board, we're very proud to have introduced our new formula, next generation extruded polystyrene made with our blowing agent. Actually has 90% lower global warming potential. We're extremely proud to say that it's manufactured with 100% renewable wind electricity, and it has a huge environmental impact. And so that is the product that we are promoting in the marketplace. to address vapor drive and also enhance occupant comfort with respect when you're using low permeance insulation. And I'm just sharing these with you. We do have our environmental product declaration sheets for each one of our products. And again, we're extremely proud. You can see when we compare our next generation foamular boards to our legacy boards, the significant environmental improvement from global warming potential, embodied carbon content potential, and ozone depletion potential. And with our fiberglass that we would like to recommend using in hybrid system in basements, again, we just launched our next gen fiberglass installation, which is also made with 100% wind powered electricity. It's got all of the environmental benefits that you see on the screen. We use a lot of recycled glass to produce our insulation. And one thing to remember, it's non-combustible. A lot of times we have a tendency to think that mineral wool is the only product that's non-combustible. We have both mineral wool and glass, and both products are non-combustible and can be used in a basement. And again, we do have our environmental product data sheet that really outlines the benefits of our next gen fiberglass insulation products, as well as our foamular NGX products. So when it comes to sub-slab insulation, so insulation under a slab, I showed you previously on the slide that if you add insulation under the slab in combination with a wall system, there's the benefit from a heat loss perspective. You saw that we got up to a 38% reduction in heat loss when going from no insulation under a slab up to a certain level of insulation. So the benefits really are thermal, moisture, air, and vapor. And so thermal is what I just explained. And then when you put insulation under the slab, you feel more comfortable when you walk across the space. You don't have any more cold feet. And most importantly, you provide the option to the homeowner to kind of put in any type of floor finish in the future, because the slab being warmer is not prone to risk of condensation, so you don't have any moisture issues. And so it allows more options for the homeowner to consider later on when they occupy the home. Obviously, better moisture control. Low permeance extruded polystyrene insulation is a perfect moisture barrier. And it's also, you'll see, we have a system that you can use it as an air, and it's also a vapor barrier. So you don't need additional polyethylene for moisture and vapor control. And by taping the joints, as you'll see in a couple of slides, you can turn into an effective air barrier. And so here, again, what I'm trying to show here is underneath the slab, depending on the type of hybrid system that you're using, the combination of continuous insulation and fiberglass insulation, you can see the heat loss impact when you've got no insulation under the slab and when you start insulating under a slab. And so for all cases, for all regions, you can see that there's a significant amount of heat loss reduction, therefore energy efficiency, that is to be had when you insulate under the slab. So even if the code doesn't require, putting it in is not only going to make the building more energy efficient, but it's also going to help provide the occupant feel more comfortable. And you'll see you can also use it as a radon barrier, which is also very, very exciting. And so just because the code doesn't mandate it, doesn't mean it's not a good choice to put in, because there's a lot of added value that comes with it. And so you can see here, just from an energy savings perspective, this is an analysis that we ran with an energy evaluator in Western Canada for a project. And so you can see in that climate zone 7A, the benefits of R5 or R10 under a slab from a cost savings, energy efficiency perspective. And so it's still, depending on the cost of energy, electrical energy, in Western Canada, the region we ran it in, it was 8 cents a kilowatt hour. You can see you can still generate a significant amount of energy savings, up to $400 a year, which you can divert to other things. And again, if we compare the hybrid systems to a typical R20 bath system, you can see the advantages clearly on this slide. So from a surface temperature perspective, the hybrid systems are much warmer. So the temperature of concrete on the warm side is much warmer and therefore less risk of condensation. And then take a look at the temperature of the slab. So with no insulation in a R20 BAT system, the temperature of the slab is about 2.4 degrees. Whereas when you use a hybrid system and you start using a little bit of insulation under the slab, you can see how much warmer it gets, an increase of about 10 degrees. An increase of 10 degrees from a surface temperature perspective is huge from a thermal comfort perspective. Think about moving your thermostat in your house from 21 degrees to 19 degrees. Just that 2-degree swing, you feel it. And so when you're walking on a slab that's at 2 degrees, and when you're walking on a slab that's at 14 degrees, you're going to feel that difference. That's the occupant comfort. That's the comfort perspective that you can achieve by insulating under the slab, even though the code doesn't require it. And so that's a huge benefit. And then the type of insulation is important. It's important. You want to make sure that whatever you put under the slab, you're not going to break that slab during at least you don't plan on breaking that slab over the duration of the house. And so you want to make sure that the product that you're choosing is durable and is not affected by moisture or vapor, and can also contribute to added benefits there. So it's important, the type of insulation. We're installing under a slab or on the outside of a foundation wall that's in contact with the soil that could be wet. There's a lot of vapor, there's a lot of moisture. You need to be conscious of that and pick the right product so that it's durable, so you don't have to go back and fix the problem later. And so there are code requirements for dam proofing and vapor proofing under concrete slabs. And a polystyrene, extruded polystyrene, low permeance can qualify as a dam proofing layer as well as a vapor barrier because it meets the requirements in the code. And so one of the added benefits of using XPS, extruded polystyrene, is you don't need a 6 mil poly because it actually acts as a vapor barrier as well, whether it's on the floor, under the slab, or on the wall. And then radon. I mean, radon is a big deal. It's a colorless and odorless gas. It seems to be more and more present in our basements, and it's the silent killers. I mean, it kills a lot of Canadians and Americans on an annual basis. And I know that the building codes are starting to address this. There's a lot of effort that's being done as we speak to kind of improve the code language so that we provide this level of safety for all new homes being built across Canada. And you can see 1 in 15 homes in the US and Canada has high radon levels. And how does it come in? Through diffusion and air leakage. And so you can see here an article in the Toronto Star for the different regions across Canada, the different levels of radon that are found in homes from low to high, low, medium, and high. And you can see that even though Canadian guidelines for radon is to be below 200 becquerels per cubic meter, even at that level, there's quite a significant percentage of homes that are actually being exposed to those levels. And if you take it down to what the World Health Organization recommends, down to 100 becquerels per cubic meter, there's even more and more exposure. So I guess what we're saying is, even though there's none initially, it's always good practice to ensure you've got, a proper solution under the slab to minimize radon infiltration or ingress long term. And so the building code does require a radon barrier to be installed. And typically, what it calls for is an air barrier system to minimize air leakage and radon ingress. And if you're using an air barrier membrane, it prescribes polyethylene as an acceptable solution, and it's got to be sealed. And so if you look at the CGSB standard for radon, you can clearly see that in order for polyethylene to fully function as a radon barrier, diffusion barrier, it needs to be sealed. And oftentimes, what I've seen done in the market in the field is poly is installed, but we don't seal it on the edge. We don't make it continuous the way we're supposed to make it continuous. And if you don't do that, that's where leakage occurs, and that's where radon diffusion comes in. So here's an example of a picture on site. What we typically see is polyethylene being installed, and it is a little bit not puncture resistant. And so if you have holes in that, in the poly, it could lead to diffusion ingress. But most importantly, it's really the perimeter seal that I don't typically see quite often. That's very, very important. I hope this video works here, but this is an air leakage test that we ran under the slab. And you can see the smoke that was coming out along the perimeter edge just because the poly was installed, it was turned up on the foam here, but it wasn't sealed. And so all of that perimeter air leakage that's occurring, think of that smoke. If that smoke is radon, that's unacceptable. And so we need to solve that. And so this is where we're extremely proud to bring to the marketplace our radon barrier, radon abatement system. And so really what it is, it's a very simple system. It uses our low permeance extruded polystyrene insulation for walls and slabs. And then basically we seal the joints with 3 sealing options: flexible caulking, our qualified tape, or our propane comfort seal spray foam seal. And so the board itself is a radon barrier. We are currently in the process of finalizing our CCMC approval for the system. So if we compare radon gas diffusion through a 1-inch extruded polystyrene board to 6 mil poly, our board lets 50 times less gas permeate through it than 6 mil poly. And when you look at the system performance with all of the edge seals and all the penetration seals, it outperforms what is referenced in the code today, 6 mil poly. And then there's the added features of 1 product, 5 attributes. So you've got air barrier control, moisture barrier control, vapor control, thermal control, and radon barrier control, all in one. So insulating the slab, now you can address all of those critical control layers and really provide a safe, durable, healthy, lower living area. And so really in conclusion, in terms of the presentation today, what to consider, exterior insulation is a good option. Hybrid interior insulations are great options. However, you need to balance them properly. You need to have the right ratios, the right amount of low permeance and the right amount of insulation in front of that for it to be durable. One of the advantages of using a mineral fiber insulation in the basement over top of foam is that it also acts as a thermal barrier. So you don't have to finish the basement if you chose not to finish it. So that's another advantage. So again, at Owens Corning, we're extremely proud to bring together for the marketplace complete enclosure solutions. I just talked to you about the lower living level solutions that we are working on and bringing to the marketplace, but we have similar packages for above grade solutions as well. And as Sonia mentioned, hey, Louis and I are there to support all of our customers and any builders that want to, desire any input or help on how to integrate some of these solutions so that you can provide your future home buyers with, a safe, durable, and energy efficient homes. And like Sonia mentioned, in conclusion, we are going to dive a lot deeper into these topics that I just lightly introduced at our upcoming Better Basement session with Buildability with Mike Leo. And the session with CHBA, I don't see my screen here, Sonia. It's November 4th, 2021. It's a 4-hour session. It's limited to the first 30 participants because it's very interactive. We're going to look at a lot of details and we're going to look at a lot of information, but we want it to be very interactive. And if we see that there's more and more people above 30 that are interested, we do have other dates, like Sonia mentioned, that are available for us to open up. Because I think it's an important topic. It's an opportunity to sell value, and it's not difficult to do. It's just a matter of understanding the principles and then having the desire to implement. And I think that's what I've got, Sonia, in terms of content for today.
Awesome. And you are like right on the nose with the timing. Look at you.
Wow.
That was an awesome presentation. Thank you so much. Some great new information in there that I think a lot of us probably haven't seen before. So thanks so much for sharing that. We do have some questions that have come in. Zoran is asking, what is the difference between waterproofing and damp proofing in terms of materials chosen?
Yeah, in general, waterproofing and damp proofing, so think of your dimpled membrane. That's what I would consider waterproofing because it eliminates hydrostatic pressure. Damp proofing is a material that prevents transfer of water or vapor in the absence of hydrostatic pressure. So that's kind of, in reality, the code requires both. They require damp proofing and waterproofing. And so if you're using a dimpled membrane over top of bituminous waterproofing, damp proofing as an example, that's acceptable. If you want to replace the dimpled membrane with a product that has integrated drainage capabilities in it, and that would be your waterproofing layer.
Great.
I hope I answered the question.
Yep, sounds good. Thanks so much. And then we've got Leah is asking, what kind of materials are used for the footing capillary break?
That's a good question. Like I said, typically it's membranes. A lot of the companies, Casella Dorkin, some of the membrane manufacturers, they've got it. It's probably 36 inches wide. It comes in a roll, and so you pour your footing. You lay out your membrane. You put in, if you choose, if you don't have a key, you'll put in your dowel rods, and then you pour your wall over top of that. But it's similar to peel and stick membranes. That's the type of texture, and it's available by many of the membrane manufacturers.
Great, perfect. So Leah, let us know if you need any follow-up on that, but I think that was a great response. Richard is asking, can this be used for methane mitigation as well under insulation, under slab?
That's a great question. I don't have an answer for that. Like the testing that we're doing right now at the CCMC is for radon. That's a good question. I don't have an answer for you, but I could look into that.
Great, yeah, wonderful. Because I've heard similar questions in the past as well. So I think methane is becoming bigger issue.
And keep in mind that the system that I disclosed, the radon abatement system, so it's preventing radon gas to diffusion. If you have presence, you still need as an example, a gravel layer with the encapsulation tube and then an extraction fan to pump it out. So that's a complete system. We're just talking about in terms of the radon abatement barrier, the barrier, as opposed to using poly. We're saying, hey, use extruded polystyrene. You've got that. You use it as a radon abatement barrier, but you've also got the added benefits that I talked to you about: comfort, surface temperature, durability.
Yeah, exactly. So this is a passive approach, and then there's the active systems, and then there's also on top of that, then the housing, like with net zero, at least they also have a ventilation system to bring more fresh air in and exhaust it. Yeah, so there's a bunch of different levels of process there. Okay, let's see here. Zoran is asking, with radon, do we need poly if the slab is 25 MPa?
Again, a great question. If you look at the current language in the building code, it does call for poly because that's what's been approved or prescribed as a radon barrier. And it's interesting you mentioned that because even the thickness is currently under investigation. Typically, I believe it was intended to be 10 mil and not 6 mil. But I think it's anyway. So to answer your question is, I don't know if you can prove somehow that 25 MPa concrete allows less radon to diffuse through it than what is currently referenced in the building code, which is 6 mil poly. As long as you seal it on the edge, you'd be fine. But you'd have to have attestation that's acceptable.
And then I guess on top of that, you'd also depend on what building inspector you have and whether or not they have the same interpretation, right?
Yeah, well, that's why you could always use third-party authorities like CCMC or UL to do the testing and demonstrate compliance. But you have to show compliance because right now in the building code, what is prescribed is 6 mil poly, sealed, properly sealed all around.
Perfect. All right, Zoran, let us know if you need any more information on that. Paul is asking regarding the survey question using insulation slabs. He continued to say, note underheated slabs and R16.1 effective is required.
Yeah, that's and thanks for reminding me. I meant to talk about that, and I forgot there. But so what I talked about is kind of showed you the advantages of insulating under the slab when it's not required. But when you have insulated heating systems, you absolutely need to insulate, because or else you're losing the whole benefit, because you're losing it to the ground.
Yeah.
So thanks for that. Yeah, in that case, that's you need it. And then if you actually can use it also as a radon barrier and an air barrier, not have to put poly as a vapor barrier, you've got the added benefit.
Great, perfect. Thanks, Paul, for that highlight. Joseph is asking, will there be another webinar for building better basements scheduled? The November 4th one is full. So Joseph, I believe that you heard from Sal that there are 2 potential dates available. So if you're saying November 4th is already full, so I'm assuming that during the course of the webinar, we've had some more folks sign up. Just let me know and we can get you hooked up. I don't have the links yet to the other 2 dates, but the other 2 dates are October 21 and October 28. The same time, right, Sal? From 1 to
1 to 5.
1 to 5 Eastern. Yep. Okay, perfect. So Joseph, let me know, send me an email afterwards and we'll get you the links to one of those other 2 sessions. Oh, and then Paul also specified regarding the under heated slabs. He also specified using 936 energy code. Okay, so it looks like he's put it in again. Sorry, he's had that in a couple times. And then he said merci, so I think he's good. And Joseph has now asked, do you have any suggestions on how to deal with condensation that occurs in continuous insulation basement wrap?
Continuous insulation basement blanket, is that it?
Wrap.
I'm assuming that's blanket.
Yeah, like I'm guessing. So Joseph, I don't know if you're able to type in there to specify when you say wrap. Are you talking Tyvek? Are you talking poly? Let's see if he gives us any more information. Yeah. Yes, blanket.
Yeah, so I mean, so the issues that we've seen associated to a basement blanket is the condensation that we're seeing is attributed to air leakage. So when you drop the blanket down the wall, the bottom of that blanket needs to be properly sealed to prevent air leakage from happening. So if you've got air leakage and you've got warm, moist air that makes its way behind the blanket, you saw the temperatures on the face of the wall that could be up to minus 19 degrees, and that's why it's condensing. If you prevent that water vapor through air leakage from getting in behind and touching that cold surface, you don't get the condensation. So really addressing the detail at the top and at the bottom of that blanket in terms of eliminating air leakage should solve the problem.
Okay, great. So Joseph, I'm hoping that answers your question. Yes, he said thank you. So we're good. And I don't have any more questions here from the audience. So I think that wraps it up for today. So like we said, if anyone wants to come to that other session, the longer webinar, I guess it's not a webinar, it's more like a seminar, please let me know and I will get you connected to the right links. We'll also, Sal, I believe, is going to be providing me with the links. So we'll also put it on our website. So at the chba.ca/NZ webinars. So we'll get that posted shortly as well. So thanks again, Sal, for a fantastic webinar. I appreciate your time in this, and also for everyone for joining us today. Thanks so much, and we'll see you at the next webinar. Bye for now.
Thank you so much. Thank you. Have a great day.
You too.
Bye.